I have started the recording and let us begin with the today's concept. Lastly, give me a confirmation. Is my voice is clearly audible to each one of you? Anybody, please, one. Is my voice is clearly audible to each one of you?
Yes,
Yes,
sir.
sir. Yes, sir.
Good, good. So yesterday, what we have studied these first three topics. That is definitions and the units of energy and power. Then we have seen the different renewable and non-renewable source of energy. Then we studied the thermal power plant. Now the today's agenda, that is on date 12/1/22. My today's agenda is to cover hydro power energy and nuclear energy, and if type per bit, we'll go for the solar energy too. Okay. So the question behind the point is draw hydroelectric power plant and explain the energy extraction process. In short, you have to write down the power hydroelectric power plant. Okay. So what are the different points that we have already covered regarding this? Is what is hydro energy? So hydro energy is the energy which is coming from the water. So it is the another part that the water is stored somewhere. It has a potential energy, and then it is converted into something, and then it is utilized for the development of electricity. But the energy coming out from the water is a hydro energy. So right now our agenda is to look for the hydroelectric power plant. So basically, the water is stored at certain height, and we are using that water to run the turbine. That is the concept. In case of thermal power plant, we are using the high pressure stream, high pressure saturated steam or high pressure superheated steam to run the turbine beds, and then the turbine beds are rotated in the shaft, and then electricity is generated. But here, what we are doing, we are utilizing the energy possessed by the water to run the turbines. The energy associated with the water is called as a hydro energy. So this is the dam, Koina Dam, where there is a hydroelectric power plant is located. The Koina Dam is one of the largest dam in the Maharashtra. So hydropower plant is basically the hydroelectric power plant, which is run by means of the water. The water is again, it is a renewable source of energy. So till the rain is there, till the water is there, till we have the storage of the water, we can run the hydroelectric power plant for the long period of time. A renewable energy source is one that is not depleted with the use. So the production of energy is continuously going on till the water is there. Though hydropower, the energy is due to the boiling water and it is converted to the electricity. So what is the energy possessed by the water and how the conversion of energy possessed by the water is converted into electricity, that let we see. So basically, this is the rain cycle. This is the rain cycle. The hydropower is nothing but the power possessed by the water. Hydropower energy is ultimately derived from the sun. So because of the sun, the rain cycle is going on, which drives the water cycle or rain cycle. The rivers are getting charged because of the sun energy, and then it turns into the vapor. The vapor becomes the cloud, and then cloud comes in contact with the cold air, and then the rain falls. Once the rain falls, the river gets charged. Point is, the water cycle is continuously going on because of the solar energy, and we are using that water cycle or rain cycle for the generation of stored water in the dam. So this is the basic layout, basic structure of the hydroelectric power plant. It consists of, let's identify what it consists of. Huh? So the dam consists of, this is the first point, that is the reservoir. The second one is the dam. Third one is this is the penstock. This is the penstock. Next one is the turbine. This is the vertical axis turbine. Okay. So basically, there are number of types of the turbines: high pressure turbine, low pressure turbine, vertical axis, horizontal axis. This is the one type of the turbine. It is known as a vertical axis turbine. The turbine is connected to the generator. It is the head, the total height between the tail race and head race. It is the head, total head available in the dam. The generator is connected to the electricity
Sir,
or substations. Yes,
sir,
tell me.
some joining requests are pending, sir.
Actually, I to admit is over there now, so no need to. I to admit is already activated. Okay, now okay. I to admit is already on. Let's see, auto admit is already activated over there. Now it's okay. I to admit it's activated. Okay. Now okay. Okay. Coming back to the point. So the different components of the hydroelectric power plants are reservoir. The dam is first, then the reservoir, then the penstock is there, then the vertical axis turbine is there, then the generator is there, then the power station is there, and the distribution center, that is the electricity. This is the head. The head in between the height in between the tail race and the tail race and the head. So this is the total head available at the power plant. So reservoir is there. This is the reservoir. The dam is there, so the dam is important. The gate, so sluice gate is not shown over here, but in the next layout there is a gate. The penstock is this penstock. Then control room is the control room where the electricity generation is controlled. The turbine, it is vertical axis turbine, and the tail race. So it is not like that we need a vertical axis turbine only. Based on the construction, based on the layout, we can change the horizontal axis and vertical axis, no issue. So this is, in that case, here it is a vertical axis turbine. So if you see, this is the cups, or it is called as a well, or it is called as a runner, or it is called as a bucket. So it is this kind of the buckets are there. Bucket or runner or cups, uh, all means the same. Okay. So this is the nozzle. This is the nozzle. This is the needle ball. We are focusing on what is the arrangement of the cup, that is turbines, turbine blades, and the nozzle. We'll be looking for its working. So this is the penstock end. This is the penstock end. It consists of the needle wall. So this is the needle wall. This is needle wall is responsible for the opening. Once it is go inside it, the opening is completely closed. If it enter partially, the partial opening is open. And in order to control the flow coming out of the system or coming out of the penstock, we have to adjust the needle wall. Okay. It is just like a tap you are using at home. The water required is high, then in that case you will be opening the tap completely. If the water requirement is less, in that case you will be partially opening the taps. So the same is needle valve. So this is the buckets. Now here it is the horizontal axis turbines. The buckets are there. So this is the nozzle, and the water is striking on the buckets. So once the water strikes on the bucket, it starts to rotate. Okay. So the rotation is around, the speed of that rotation is around 30,000 RPM. So 30,000 revolutions per minute is having huge RPM speed of your turbines, turbine blades. Okay. So again, this is your turbine blades. This is the buckets, turbine blades. This is your penstock. This is the casing. This is your blades, turbine shaft. The assembly is connected to the generator, and the electricity will be developed. So this is the basic layout. Let's move towards how does exactly it works. Okay. So As far as the hydroelectric power plant consists reservoir, dam, generator, electricity, dam, reservoir, transformer, powerhouse, then distribution line. So what exactly the basic function of each and every part, that is our point to look out. Okay. So the reservoir, it is the section where the water coming out from the river is stored at a certain height. The reservoir is just a passage. The reservoir is just a passage which is used to store the water in the dam. The dam is made up of the concrete structure which is used to prevent the flow of the water from one area to the another area. The sluice gate or intake. So intake is connected to the penstock and it has the opening through the control gate. So intake is a passage to move the water into the penstock. It is moving into the penstock through the control gate. So the control gate plays an important role. The function of the control gate is to allow the required quantity of the water to flow through the penstock. The 100% opening of the gate, in that case, the quantity will be the 100% going through the penstock. If it is not, it is 50% open, then in that case only the 50% is water is allowed to go through the penstock. So based on the amount of the electricity required or based on the amount of RPM required by the turbine, we have to control the discharge of the water. If the high discharge of the water, in that case the RPM will be high. The RPM will be more, in that case we'll be getting the high energy. But every turbine is restricted with its specification. Specification means we can move the turbines or we can rotate the turbine at specified speed only. So even though the turbine blades can rotate to 30,000 RPM, we do not require that much high RPM. So in order to control its RPM, we have to control its motion. So the motion of that turbine has to be controlled through the flow of the water or the discharge of the water, and that is controlled by the control gate. Say the water is coming through the penstock. Now the penstock, it is a passage which act as a conduit. It made up of the steel or it made up of the concrete. So it is just a passage which allow water to come and to come in contact with the to carry the water from inlet till the reservoir. At the end of this point, the arrangement of this is the penstock. At the end of this, there is a nozzle. The nozzle is used to convert the high pressure water and allow to strike that high pressure water over the buckets. Once the high pressure water strikes the bucket, the turbine blade starts to rotate. Once the turbine blade starts to rotate, whole turbine shaft starts to rotate. And ultimately the turbine shaft is connected to what? In case of the thermal power plant, the turbine shaft is connected to what? Anybody? Turbine shaft is connected to?
Generator.
Very
Generator.
good. Perfectly correct. So the turbine shaft is connected to the generator. Then when the turbine shaft is connected to the generator is located into the powerhouse. So the generator is again connected to the transformer. So that may be a step up transformer or that may be a step down transformer. The step up transformer means when the electricity is the generator is less, in that case it will step up. It will increase the intensity of the electricity. If the electricity is down high, in that case it will be step down transformer. So once the generator generates the electricity, it allows to pass through the distribution center, through the powerhouse, through the transformer. Now what once the water strike, it will allow to go into the tail race. Now this tail race area is utilized to utilize for the different function like agriculture functioning, like sport utilization, like processing and so on. So this is the next part of the utilization. Once the primary function is to utilize that amount of the water, X amount of the water to develop the electricity, and the remaining discharge water is allowed to do some secondary tasks like irrigation, farming, sporting, clubbing, and so on. So this is what the hydroelectric power plant is. What are the different advantages associated with this? Number one advantage is it is pollution free. The advantage is very, it is, there is no like combustion of fuel and exhaust gases, so it is not hazardous to the nature. Okay, so it is pollution free. The second one is once the dam is constructed, once the dam is constructed, we can have electricity from it through the long period of time at a constant rate. If we have the water, if we have the water, in that case, once the dam is created, we can develop the continuously a constant amount of the electricity. Second, the water storage will have a water storage definitely. Then the dam is designed to last many decades. Once the dam is constructed, it is having the life like hundreds of years. So no issue for that. And it is the pollution free. So these are the few advantages from your end. You can add more to, no issue. What are the disadvantages associated with this? Number one disadvantage is somebody is asking me something. No? I'm getting pop-up. Okay, so many people are there. Okay, everybody join. Sir, some request. Okay. Okay, no issue. So we have done the advantage point. Now the disadvantage point is, dam are extremely expensive to build and must be built to at very high standard. So it is has to be built at very high standard, and the construction of it is very expensive and time consuming. Once the dam construction is started, it takes a 3 year to 3 year, 4 year, 5 years of time to construct the complete dam. So this is one very important disadvantage. The second is plant is located away from the load center. Means like we are living in the Nasik properly, and the dam is constructed like 30, 40 kilometers away from the city. So it is located very away from the load center. So to carry the electricity from the plant to the city, there are the transmission losses. So we have to face the transmission losses. So, and the last one is the setup time, that is the construction time required for the hydropower is very long. So 3 to 5 years minimum time required to construct the dam. Minimum 3 to 5 years required to construct the dam. So this is all about the nuclear power plant. If anybody is having any doubt regarding the nuclear power plant, you may can ask questions. Nuclear power plant, the hydroelectric power plant. Again, I have shared link for the attendance in the chat box. Those who are pending, you may can do the attendance. For hydroelectric power plant, if anybody is having any doubt query, you may can ask. If no, then give me thumbs up so that I'll go for the next type of the power plant. Any doubt query? Anybody is having any doubt query? How many maximum speed turbine rotations? How many speed? How many speed? Max. See, because of the water quantity, the turbine blade can rotate up to 30,000 RPM. But it is not a requirement. The 30,000 RPM is a very huge RPM. But we have to rotate that, say, approximately 12 to 14,000 RPM. That is enough to develop the electricity. And at 30,000 RPM, there is no generator is over there to carry that much high capacity of the RPM to develop the electricity. So even though we have the quantity of water to supply the supply to the turbine, we have to control the RPM of that turbine, and that is why the nozzle or needle wall is present into the penstock to control the discharge of the water. Anybody else? You can unmute and you can talk to me, no issue. If anybody is having any doubt, you may can ask me. Else, give me a thumbs up so that I'll start with the next power plant. Anyone? Anyone else? If no doubt, give me a thumbs up so that I'll start. Okay, Kiran Rao, good. So the next point of mine is nuclear power plant. So the question associated with the nuclear power plant is, nuclear power plant is draw neat sketch of nuclear power plant. So let's begin with the nuclear power plant. See, the nuclear power plant is nothing but it is one type of the thermal power plant. And the difference is only that instead of boiler for the steam power plant, we replace by the nuclear reactor. Nuclear power plant and the thermal power plant both are same. Only the difference is in case of the thermal power plant, we are developing the steam through the boiler, whereas in case of the nuclear power plant, we are using the nuclear reactor to develop the electricity. So my question to each one of you is, can anybody tell me the flow of thermal power plant? What happened? I'm telling you the component name. You have to tell me what happened at that component. Okay. So in the boiler, what happened? What is the function of boiler? What is the
Convert the water into steam.
perfectly correct? Then the superheater.
It converts wet stream
wet
into dry
water vapor
stream.
into dry
Very
stream.
good. So what is the temperature of that dry steam?
170,
More than 180 degrees Celsius.
180 degrees Celsius.
Minimum 180 degrees Celsius. Perfectly correct. Then that dry steam is allowed to pass into which component?
Turbine.
Turbine.
Perfectly correct. Then the output of the turbine is which energy?
Mechanical energy or
Mechanical
rotational
energy.
energy.
Mechanical
Very
energy.
Mechanical
perfect,
energy.
perfectly correct. So the turbine is connected to
Generator.
Generator.
perfectly correct.
Generator.
Whatever the steam coming out of the turbine is connected to which component?
Generator.
Condenser.
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 What is the function of condenser?
Converts water vapor into water.
Is, perfectly correct. To convert the steam into the water.
Water.
Convert steam into water vapor.
Water vapor ne water. Okay. So that water is allowed to pass into feed pump, and then the feed pump
Water
is,
pump.
and then the water pump allowed to pass that water into the boiler again.
Boiler.
Very good, nice. So right now the plant is same. Only we are replacing your boiler by means of the nuclear reactor. Okay. So nuclear power plant consists of nuclear reactor. The first was the boiler in case of thermal power plant. Right now I'm taking over here as a nuclear reactor. Nuclear reactor is there. The moderators is there. Control rods are there. Steam generator is there. Steam turbine is there. Pump is there. Then the feed pump is there. Then the heat exchanger. So heat exchange. What do you mean by heat exchanger? I have already told you in the previous session. What do you mean by heat exchanger? Anybody? Heat exchanger is any device that is used to exchange the heat of different fluids. That maybe it is used to raise the temperature of some fluid, or it may use to reduce the temperature of other fluids. So it is only the medium, or it is only the component which is used to exchange the rate of heat. Okay, from low temperature to high temperature, or from high temperature to low temperature. Okay. Nuclear fuel. So, what are the different nuclear fuels? The
Uranium.
most commonly used nuclear fuels are uranium, that is U-235, and thorium 232. These are the two basically used nuclear fuels are there. But along with that, we can use the plutonium. Plutonium 239 is also nuclear fuel. So uranium, thorium, and plutonium, these are the three different nuclear fuels that we are using. So how does that nuclear fuels comes into the picture, or what exactly they are doing to develop the electricity? Consumed to drive the nuclear energy, the most common type of the nuclear fuel is the element that can made to undergo the nuclear fusion chain reaction in the nuclear reactor.
Huh?
So please unmute yourself. Those who are there, please unmute yourself. So, nuclear fuel, beta, somebody is there. Please unmute yourself.
Sir, your voice is breaking in between.
Hold a second. Please, those who are unmuted, Kiran Raut, please mute yourself, beta.
Hello.
Yes, who is there? Who is there? Hello? Now voice is clear? Hello?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
No, voice is clear, no?
Yes, sir.
Yes.
Okay, okay. Please mute yourself. Okay. So, nuclear fuels. So, uranium, thorium, and plutonium, these are the three different nuclear fuels that we are using into the nuclear reactor to develop electricity. And these all fuels are nuclear fuels are subjected to a nuclear fission chain reaction. So the electricity is
Hello.
developed. Yes. Hello. Yes. Who is there? Yes. Bhakti Deshpande. Hello. Hello. Anybody else?
Yes, sir.
Anybody is saying hello, no? So that's why I come back to you. Okay. So shall I start?
Yes, sir.
Okay, great.
Yes, sir.
So uranium, thorium, and plutonium, these are the three nuclear cells we are using for the electricity generation from the nuclear fuels. Okay. But these all are fuels has to go through the nuclear fusion reactions, nuclear fission chain reaction. So what is nuclear fission chain reaction? Let us see. When a neutron strike on atom of uranium, or we can say nuclear fuel now. So we have seen the three different nuclear fuels. So right now I'm not taking the specific name of any nuclear fuels. So I'm just telling when the neutron strike to the atom, it's split into two higher atoms or two lighter atoms and release the heat simultaneously. So when the neutron strike to the atom of any nuclear fuel cells or any nuclear fuel, in that case, it releases the two lighter atoms with the release of heat, means exothermic reaction. Which reaction? Exothermic reaction. Neutron strike to the atom will split into two lighter subatoms with release of heat. So the reaction is called as the exothermic reaction, which releases the heat. The fusion of heavy element is an exothermic reaction which can release a large amount of energy both as electromagnetic radiation and kinetic energy of the fragment. So when the reaction takes place, the reaction releases the huge amount of the energy as it is a exothermic reaction. This is unstable atom liberate the large amount of heat and the fission of this is very important, the fission of 1 kg uranium is equals to energy obtained by burning of 4500 ton of coal. So 1 ton stands for how much kg? 1 ton stands for
1000 kg.
10,000.
1000 kg. 1 ton stands for 1000 kg. So look, 1 kg of uranium is equals to energy obtained by the burning of 4500 into 1000 kg of ton. So 4500 ton of coal burning and around 2200 ton of oil burning. So once we burn a coal of 4500 ton or once we burn a oil of 2200 that 2200 ton of oil, so that the heat, whatever the heat will obtain, that is around equivalent to the nuclear fusion reaction of 1 kg of uranium. Okay. So how does nuclear fission reaction takes place? Let us have a look. Before going to the nuclear fission reaction, please tell me what are the different nuclear fuels? What are the different nuclear fuels?
Uranium, thorium.
Uranium.
Uranium, thorium, and plutonium.
Plutonium.
Very good. So the second question is, one if I undergoes a nuclear fission of 1 kg of uranium, that is equivalent to the combustion of how much ton of coal?
45,000 ton.
4,400.
4,500. Perfectly correct. And what about oil?
2,200.
Around 2,200 kg of oils. Very good. 2,200 ton of oils. Very good. So let us see the nuclear fission reaction. When a neutron strike an atom of uranium, the uranium split into two lighter atom and releases the heat. So this is, say, this is uranium atom. Once this neutron strikes this atom, it will split into two subatoms, lighter atoms. But when this happens, there is a nuclear fission, and during which we are having the energy. So this that much part is only the first generation. In the first generation, some amount of the energy is released. Okay. So this is exothermic. First neutron strikes the atom, develops, split the lighter two atoms. In the next generations, the fusion of heavy element is an exothermic reaction which can release the large amount of the energy, both as the electromagnetic radiation and the kinetic energy fragment. So, if this one strikes to this, there will be a splitting of this. Now, this will split into two different parts. Now, again, this will strikes to one, this will strikes to the second. Again, it will split. Whenever there is a bombarding of neutron over the atom, the splitting is continuously going on, and so on, so on, so on, so on. This reaction is uncontrollable reaction. At every generation, first generation, second generation, third generation, fourth generation, till the neutron strikes to the atom, at each and every step, there the generation of the energy takes place, exothermic reactions. So, because of this reaction, but this reaction is not taken place into the open space, because if it's taken place into the open space, the reaction will continuously goes on. There is no control, so the huge amount of energy will be liberated. In order to control those reactions, we have to carry out this reaction into the nuclear reactor, along with a few components, so that we can control it. Let us see how to control the nuclear reactions, nuclear fission reactions. Basically, this is the plant of nuclear power plant. Let us see. Don't consider the 50% part of this. Focus on that. This is your turbine, traditional turbine. This is your generator. This is your distribution line. This is your load. Okay. So the steam is over here. Steam generator or steam is coming and striking to the turbine. Now here the condenser is there. So condenser is collecting the condensate and pumping it to the water. Okay. So I guess the 50% part, you are very much familiar with this. What is the function of turbine? What is the function of generator? What is the function of condenser? You are very much familiar. Now the part is the reactor vessel, or this is the control shells. Okay, so we have to focus on this. I'm just going to explain the nuclear reactor. The remaining part you are very much familiar to you. Nuclear reactor. A nuclear reactor is a device in which the nuclear chain reaction is initiated, controlled, and sustained at a steady rate. So nuclear reactor is a reactor where the nuclear reaction takes place in a control actions, where we can initiate, we can start and control the reactions. As opposed to nuclear bomb, in which the chain reaction occur in a fractions of second and uncontrolled, causing the explosion. If we are not controlling this, the explosion will occur and the continuous heat will be developed at the each and every generations. So what is the moderator? The moderator is a component. See, moderator is the device which is used into the nuclear reactor during fission. Neutron moving very fastly. So actually, the process is because of the neutron bombarding on the atoms. So we have to control the movement of the neutron. So the moderator, it is a device which we have to control. During the fission, neutron moving very fastly. These neutrons are slowed down to right speed so as it increases the effectiveness of fission. If the continuously atoms are releasing, continuously neutrons are releasing, and it is moving very fastly, so the chain is going on very fastly. So in order to control this chain of bombarding of neutron over the atoms, we have to control the speed of neutron. The moderators are placed in between the way of the neutrons so that they pass over the moderator, and moderator will control the speed of the movement of neutrons. Control rods. The control rod made up of the material that absorb the neutrons, and are inserted into the bundle using the mechanism that can rise or lower the control rods. So control rods are the rods that absorb the neutrons, which is having the mechanism of insertion of control rod in between the process, and we can insert the control rod during the mechanism or during the nuclear chain reaction, and we can remove it after the reaction. So control rods are using to absorb the neutrons, and moderators are used to reduce the speed of the movement of the neutrons. High energy in the fusion need to be controlled. It may melt the entire core. If the energy is developing is in the continuous way, it damages to the entire core. Entire core means the entire safety room of the controlled reactions, or it may melt the nuclear reactor. The control rod easily contain the neutrons. It absorbs like boron, cadmium, and iridiums. External shields. So it is shield in which the nuclear reactor is placed. It is the safety. It is the safety compartment or rooms in which the operators and the surrounding can be placed for the controlling the operations. Heat exchanger. So a heat exchanger, it is any device which is used to exchange the heat from low temperature to high temperature, or high temperature to low temperature. It absorbs the primary coolant in the reactor and it is given to the water stream. The primary coolant is CO2, sodium, and the potassium. So these are the coolant. The high pressure water or high temperature water or stream is allowed to pass over this so that the temperature of those are controlled. So water and steam can allow to pass over the primary coolant. So the heat exchange takes place in between the water stream and this coolants. Steam turbine. The function of steam turbine, you know very much, to convert the high pressure steam or dry steam into the mechanical energy. Okay, so just have a look. This is a steam generator. Now the control rods, the rods which shown into the this 1, 2, 3, 4. These are the control rods. These control rods can be inserted into the reactor and it can be removed from the reactor whenever required. And this is only because of to absorb the atoms, neutrons, not atoms, neutrons. The moderator is also placed in between in order to reduce the speed of the neutron. Advantages and limitations. The first limitation is the setup cost is high. The setup cost is high, but setup cost is lower than that of the hydroelectric power plant. The nuclear fuels are not easily available. The cost of nuclear fuel is high. During operation, nuclear reactions are proposed, hence the degree of safety to the operator is very much high required. Okay, so this is all about the nuclear power plant. If anybody is having any doubt, could you please ask me so that I will be solving your questions. Anybody is having any doubt, could you please ask me? If no, then let me allow to ask you a few questions and then let's move for the next part. Please repeat. Bhakti, please ask me which point you were not getting so that I will be repeating that only. To repeat complete session is not possible.
Sir, the diagram you showed just now.
This is the diagram.
Yes, that one.
Okay.
Containment structure.
Okay. So this is the complete layout. Okay. This is the load, means your home, you're setting over here. This is the load. This is the distribution line. That is the MSCB. From this, you're getting the electricity. Okay. Now this part, this is the steam generator. Okay. So this is the steam generator. It is similar to that of the steam collector in your thermal power plant, where the steam is developed by means of the water. The water is injected into the thermal power plant, and the steam is developed. So this red line you're looking now, this is flow. This is the amount of quantity of the heat passing through this water tank, so that the heat is exchanged in between the water which is coming in contact with this pipe. So because of heat, it will allow the water to heat up, and the steam is developed and it is collected over the steam collector, and the steam, dry saturated steam, is allowed to pass over the turbines. Okay. Then look at this steam reactor. Huh? You can see this 1, 2, 3, 4. This is nothing but the control rods. The function of control rod is they are absorbing the neutrons. We can insert this in the nuclear reactor and we can remove this from the nuclear reactor. If I see the nuclear reaction is going on very fastly and I have to control the nuclear reaction, in that case I have to absorb some sort of neutrons. So I'm putting or I'm inserting this neutron, I'm inserting this control rod into the reactor. So reactor, what the neutron comes and deposited on the this control rods. The control rod absorb the neutrons. Once I think the reaction is in control, then I'll remove that control rods. Then the smooth reaction is going on. So this is the function of the control rod. There is one more moderator is there. So function of moderator is it allow to reduce the speed of the neutrons, as the chain reaction is very fast. The neutrons are moving very fastly. So we have to reduce the speed of the neutrons. So the barrier are inserted into the nuclear reactor so that they'll act as a barrier to the flow of neutrons. So they have to pass into the multiple layers. The point is, you just focus on these 2 points: nuclear reactor, moderator, and control rods. The function of moderator is to the function of moderator is to reduce the speed of the neutron. The function of the control rod is to absorb the intensity of the neutrons, and the nuclear reactor, it is used to carry out the nuclear fission reaction of the different nuclear fuel cells. Okay, so anything else in between?
No, sir. Thank you.
Okay, great. Anybody else?
Yes, sir.
Please tell me.
Sir, moderator, the role of moderator is to reduce speed of neutrons. Yes,
Yes, yes.
it may be putting some effect on energy production.
Yes, yes. In order to control the effectiveness of energy production, we are putting the what we say,
Moderator.
moderator, so that it act as a barrier only. Like say, if you're going into the classroom now, you're coming into the classroom in the straight way, and if you're coming into the classroom by going on the first floor, and then you're going to the second floor, and then you're going into some other class, then you're going to some other class, and then you're coming into your classroom now, it will take a
Yes.
time. So the moderator is just creating a passage. It acts as a barrier to the movement of the atoms, neutrons, so that it rotate within the nuclear reactor. Okay, so it will take a time to reach up to the atom, because neutron and atom both has to come in contact. Neutron has to attack over the atom, and then the splitting will take place, and that splitting is nothing but the nuclear fission reactions. Okay, so the point is, the delay neutron bombard over the atom, net will be the generation of electricity, net will be the generation of heat, and that we are going to control over here into the nuclear reactor by using the moderator.
Yes, sir. Okay, sir.
Okay, great. Anybody else?
No, sir.
Okay. Okay. Then moving towards the next point. Okay. So I guess nuclear power plant is clear to each one of you. If it is, then give me a thumbs up in the chat box so that I'll start the next session, next power plant. If the nuclear power plant is clear to, okay, Kiran, good. Let me share the attendance link with each one of you. Those who are pending, those who have joined the session late, please go ahead and fill the attendance sheet. Those who are late, please fill the attendance sheet. Okay, today is enough. Two power plant we have covered: nuclear reactor and hydroelectric power plant. So today we will stop over here. In the next session, we will start with the solar power plant and the geothermal power plant. Have a good day. Have a great day. Take care.
Sir,
If anybody,
Thank
if
you.
anybody is having any doubt, query, please ask me. Hold a second.
PPT